In this video, we're going to look at motion and distance times graphs. We're going to go through some examples. The first example we're going to stand about 1 meter from a CBR. That's just our motion, our set place. And then for the first 5 seconds, we're going to move away from the CBR at a steady medium speed. Then we're going to stop for 5 seconds. Then we're going to move towards steady CBR at a steady fast rate. So I'm going to do my best using this applet. Okay. So right now I'm at position 0. So I'm going to try and stand about 1 meter from it. So I'm positioning myself at 1. Okay. Not really working, but I'll start at 2. And I'm going to start the clock and see what happens. So the first 5 seconds, I'm going to move away from the CBR at a steady rate. Oh, time went a lot faster than I thought. Then I'm going to stand still for a bit, and then I'm going to go back at a steady rate as much as possible. So you can see from this graph that I went up at a steady rate. I didn't move, that's why my position didn't go up or down. So I'm set at a steady rate. And then I tried to get back to where I originally was, which is here at a steady rate. So it's almost a line going down. So we're going to put that in our graph here. I'm going to actually draw in that I was 1 meter from the CBR. So this is my distance from my original place. Actually start here. 5 seconds approximately, I went at a steady rate. So that's 5 seconds. Then I stopped for 5 seconds. That's got to be a straight line because I didn't go anywhere, so my distance won't change. It stays the same for a whole 5 seconds. And then at a steady rate, I come back. So we're just sketching this. Try and make it a little more even. So let's try another example. So that's my steady rate of way. That's my stopping, so the distance does not go up or down. That's why it stays the same. And then that's me coming back to my original position. So let's try this again. Unfortunately, I can't do as far as possible, but on my applet. But if we can account for that we're standing somewhere like here. And then for the first 4 seconds, we're going to remain motionless, which means I'm not going to move. Then we're going to move towards it at a fast, steady rate. And then we're going to try increasing our speed. So we should try and going a little faster, faster, faster. Then we're going to stop for 2 seconds, and then we're going to move away at a slow, steady pace. So let's try this. So stop. I reset this. Just refresh. Okay, so I'm going to try and position myself far from this as much as possible. Let's see. And then what we're going to do is we're just going to stand there for the first 4 seconds. So I'm going to start the clock. The clock goes pretty fast, and then we're going to move towards it at a fast pace and try to increase it so we see a curve, and then we're going to move away at a slow, steady pace. So as you can see here, there's a little bit when you increase your speed, you'll see a little bit of a dip You see your speed going quite more steep. So let's try that. And this is steady. Okay, so let's try and graph that here. So we try to be as far away as possible. So this is our distance again. So we remain motionless in the beginning, which means our distance did not change. That's here. That was for 4 seconds. Then we move towards it at a fast, steady, at a fast pace, trying to increase our speed. So our speed was going fast, 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 and getting, well, that's not, it's better, fast, getting faster. So you'll see a little bit of a dip to show that it's faster. And then we just stop for 2 seconds. So it's a straight line. And then we moved away from it. So we went back further from a distance at a slow, steady pace. So this is us standing far away from it. This is motionless. This is moving towards it at an increasing speed. And this is moving away at a slow pace. So now we're gonna sketch graphs to represent each of the following situations. Moving away at a medium pace. So just moving away is simply, so I gotta start the clock. My hand is not as fast as the clock goes. Moving away is a steady pace. You'll see us go up, up. Same rate I'm going. So it's all pretty much a straight line. That's moving away. So moving away is just going, changing your distance at the same rate. And that would be just the line. Oh, it's a huge line there. So this is a medium pace. A fast pace will be steeper, so it'll go like this. It'll be like a hill that's quite steep. That's how you know it's a fast pace. Okay. So if you want to see it faster, let's start it again. Try and go faster to show you that it's steeper. Start and go. See how you see the line is faster? Oops, it dipped because I stopped. But you see this part of this is steeper. So there you have that. Moving towards it. So if we're going towards it, our distance is going to go from a high distance so we're like here and we're going towards it, so that means our distance is going to hit 0. See, that's 0. A quicker pace will be steeper, so that means I'd be getting there faster in less time. So this time would be here less versus this time here, which takes longer. You want to look at starting at 2 meters, then moving away for a short period of time at a fast pace. So all of these are distance versus time. So here, starting about 2 meters from it, moving away at a fast pace means it's going to be steep. Then stopping. Stopping is just a straight line across. It means your distance is not changing. And there you go. Moving away, stopping for a short time, then moving back at an increasing. So when it's, that should be straight because you stop, your distance should not change there. Moving away at a faster speed means I'm going to be getting steeper and steeper my lines. So that means it's going to curve downwards. It's getting steeper. It's going from not as steep a hill to a dip. Let's look at this and try and look at George's distance as he walks to school. So example here shows the graph shows George's distance from home as he walks to school. Describe his walk. Point A is George's house. Point E is the school. So here he's starting at home and he's walking to school. So let's look at each line segment and describe the graph. So A and B, he's walking away from home. This is his home. And he's going at a steady rate. Okay, so let's look at it. It's steady because it's straight line, there's no curves. So here George is walking away from home. At a steady rate. So let's see. He's gone for 1, 2, 3 minutes. And he goes a distance of 300 meters. So that's AB. That's right here. So now let's look at BC. BC is not as fast as AB because it's kind of the hill is not as steep. So he slows down, and let's see. So George slows down his walk. So he continues to walk to school. But he decreases. He decreases his speed. Oops. So here he goes in how many minutes? So he goes from 3 to 7, so that's 4 minutes, and he goes from 300 meters to 500 meters, so that's 200 meters. in 4 minutes. So you can see it took him longer to go even less meters. Here he went 3 minutes, he went 300. Here he went 4 minutes, he went 200. See, from C to D, oh, he's not moving. He stopped because his distance is not changing. So he's just stopping. So George has stopped. So he stops for, let's see, how many minutes does he stop for? 7 to 9, so that's 2 minutes. And he doesn't go anywhere, so he goes 0 meters. And from D to E, he travels how much? From 9 to 14, and he makes it, no, that's 13. So it takes him another, so another 4 minutes, and he goes from 500 to 700, so that's 200 meters. So it's the same rate as before he stopped. So it's a steady rate. George continues walking to school at a steady rate. Until he reaches school. Okay, so let's match. Let's see some more examples. Let's match graphs with descriptions. So I'm gonna match each one. So anything that's a straight line has got to be constant speed. So we're gonna look for constant speed. So walking away from home at a constant speed. That's away from home. So that's got to be number one. Toward home would be where your distance from home is 0. So that's got to be toward home. So check that one off and that one. Accelerating, that means increasing your speed. That's what accelerating means. So increasing speed means that it's getting more steep. Now towards home means that my home is at 0, so I'm going to be going steeper towards 0. So that looks like 3. Decelerating means decreasing your speed. And that's towards home. So decreasing means that you're not going as steep. So it's going to flatten out. So this has got to be it. And it's towards home means I'm going from higher to lower. Standing still means that you're not going anywhere. It's a straight long cross. So that's got to be that one. And then accelerating away from home. So I'm looking for more steep. More steep is going to mean more of a curve. And decelerating is going to flatten out. So that's the last one. Okay. We do one more example. The graph below represents Sansa's walk to school. Describe the walk. So here we have time versus distance. So we're going to make up a story. So let's label it A, B, C, D, just to help our story. So from A to B, okay, Sandra leaving the house. She's going away from house. And she walks at a steady rate. Why is it steady? Because the line is straight. There's no curves. From here, let's see. Let's put something on here. Let's go by, oops. Since there's no units. Actually, that's okay. From B to C. A little too large here. Sandra is at the store. Okay. She is purchasing her items. That's why she's not moving away from home. And then from C to D, Sandra walks back home at a steady rate. And since it's steeper than from A to B, we're going to say she walked faster. She walked home faster than she walked to the store. She walked home faster than her speed. She walked home faster than walking to the store. She walked at a faster speed than her speed to the store. Okay, so look at this. A to B, Sandra leaves the house and she walks at a steady rate. From B to C, she stops. So then when she's at the store, she's purchasing her items. So that's why it takes her a little bit of time. And then because this is steeper, Sandra walks back home at a steady rate because it's a line, but she walks at a faster speed than before. And our last graph, going to include some units here. So I'm going to put some. Let's put like 5 here for time, and 10. In temperature, I'm going to go by 10s, so 5s. For each tick mark is 5. And so on. Okay, so let's describe. Again, it's easiest to label the graph to describe it, so I'm going to label this A, B, C, D. So here we have an example that curves. When it's curved, that means that something's either increasing or decreasing. So you're looking to see if it's getting steeper or less steep. So is the hill getting more steep or less steep? Okay. So So from A to B, the temperature is increasing at what we call an accelerating rate. It's accelerating because it's getting more steep. It increases. So when you have units, you have to use them from 10 degrees to approximately 23 degrees. And it takes 5 days. Okay. From B to C, temperature does not change. So 4, 5, 6, 7, 8. So for 3 days, the temperature remains the same at 23 degrees. And then from C to D, the temperature is decreasing. So you can see it's getting colder at a steady rate. It's not accelerating, it's not decelerating, because it's not curved. It goes from 23 degrees to 5 degrees in 2 days. There you go. Every graph tells a story. That's a lesson on distance time graphs.